Appendix B.2 Graphs of Equations. Some more terms you will need to be familiar with. This is all year long. Anytime you do any graphs, regardless of whether it's lines, circles, parabolas, hyperbolas, ellipses, it doesn't matter what we're graphing, you're almost always going to be asked to list the x-intercepts and the y-intercepts. X-intercept is where a graph crosses the x-axis. To identify an x-intercept, you simply plug in 0 for y and solve for x. If we look at the coordinate plane and we think about x-intercepts or where a graph crosses the x-axis, if we look at every single point along the x-axis here, each one of those points has in common the fact that the y-coordinate of any one of those points is 0, which is why we plug in 0 for y when we want to identify where an x-intercept is. Likewise, a y-intercept is where the graph crosses the y-axis. And to find a y-intercept, we plug in 0 for x and solve for y. The reason we do that is if we look at all of these different possible y-intercepts along the y-axis, all of those points on the y-axis have in common 0 for their x-coordinate. Notation-wise, when you are listing intercepts, remember intercepts are ordered pairs, so make sure you write them as ordered pairs. Anytime we're talking about any point within the coordinate plane, we are talking about an ordered pair to describe that point. Do not write x equals 3 for an x-intercept. X equals 3 is the equation of a vertical line, not an intercept. So intercepts must be given as ordered pairs. If it's an x-intercept, the y-coordinate will always be 0 in your ordered pair. If it's a y-intercept, the x-coordinate will always be 0 in your ordered pair. Example 1, determine whether each point lies on the graph of y equals 10x minus 7. Remember, point lying on the graph could also, in direction, say solution point. Remember, all of that means the same thing. In this case, we're still given an x value and a y value. We want to know, does that make a true equation? Plug in 13 for y, plug in 2 for x, and simplify. We get 13 equals 20 minus 7. 13 does equal 13. So yes, this point is on the graph. Do the same thing with the second ordered pair. This time put negative 3 in for y, put negative 1 in for x, and simplify. Negative 3 does not equal negative 17, so we know that this point does not lie on the graph. Graph each equation, find all intercepts. At this point, I don't care what method you use to graph. If you want to put this in slope-intercept form and graph it by slope and y-intercept, go ahead and do so. Doesn't matter to me. In this case, though, since we have to already find the intercepts, let's go ahead and do that, and let's graph it by finding the intercepts. Start with the x-intercept. X-intercept. To find that, we are going to put 0 in for y. And solve, we get x equals 2, which then means our x-intercept is the ordered pair 2, 0. Y-intercept. To find a y-intercept, we put 0 in for x, which makes that entire term disappear. We're left with y equals 6, so our y-intercept, we put in 0 for x. We got out 6 for y, and now I'm simply going to plot each of those two intercepts, connect them with a line. We have the ordered pair 2, 0. The ordered pair is 0, 6. Once we have those 2 points, connect them with a line. Now a couple things with graphing. Obviously, you're sketching this by hand, so it's not going to be a perfectly straight line or anything like that. But what you should have is no matter what you are graphing, since this point and this point are the two that I have graphed, make sure your graph is passing through those 2 points. So when I go to draw the line here, I want to make sure that those 2 points are included. Once I get past each of those 2 points, I'm going to put an arrow on each end indicating that I know that that graph goes on forever in both directions. Find intercepts again. This time we're no longer dealing with a line. It doesn't matter. It doesn't matter what graph you are working with. You find intercepts the same way every time. X-intercept, I'm going to put 0 in for y. 0 equals x squared minus 2. Solve this equation for x. We get x squared equals 2. From here, take the square root of both sides. Don't forget to consider the positive and negative square root. We have two x-intercepts at plus or minus root 2 and 0. Y-intercept. We put 0 in for x, and we're simply left with y equals negative 2. So we have the ordered pair 0, negative 2. This time we have 3 intercepts to graph. Let's graph each one. We have a point at 0, negative 2. Square root of 2 is about 1.5. Negative square root of 2 is about negative 1.5. You should recognize because one variable is squared, we're dealing with a parabola here. We have these 3 points. Connect them with a smooth curve. And there's our parabola. Third one, should recognize this as being a circle. So we could graph it by center and radius, but in this case we still need to find the intercepts. We could look at this and know that the center is at 0, 0, and that the radius is 3 units from what we know about the standard form of the equation of a circle. But in this case we have to find the intercepts, so let's go ahead and do that before we graph. X-intercept, I put in 0 for y. We're left with x squared equals 9. Take the square root. We see we have two x-intercepts, plus or minus 3 and 0. Y-intercept, plug in 0 for x, and we're left with y squared equals 9. Take the square root. We get plus or minus 3. And now put a point at each one of those intercepts. 3, 0, 0, 3, negative 3, 0, 0, negative 3. Connect those points as best you can with a circle.